medians and altitudes. A median is a triangle, the median of a triangle is a segment that runs from one vertex of the triangle to the midpoint of the opposite side. The point of concurrency of the medians is called the centroid. We also talked about altitudes. An altitude of a triangle is a segment that runs from one vertex perpendicular to the line that contains the opposite side. The orthocenter is the point of concurrency for the altitudes. So, in our practice problems, we have to identify whether the line segment that's drawn is a median, an altitude, or neither. So, in picture number 1, notice that my values here are 3 and 3.2. So, I know that these two segments are not congruent. So, therefore, this is not going to be the midpoint. So, I can say that this is not a median. Now, I have a vertex here. My line comes straight across, touches the opposite side, and it's perpendicular. So, therefore, that's going to make this line segment here an altitude. Problem number 2. I have my tick marks to indicate that these two line segments are equal. So that makes B my midpoint of the line segment. This is coming from a vertex. So therefore, my line segment is a median. Picture number 3. It goes from the vertex to the opposite side, forms a right angle. So therefore, that is going to be another altitude. Problem number 4, I don't know anything about my line segments. I don't know if this is a right angle. The only thing I know is these two angles here are congruent, which doesn't help me any, so this is going to be neither. It's neither an altitude nor a median. So, problem numbers 5 and 6, I need to identify and name the centroid. Number 6, I'm naming the orthocenter. So, in our problems above, in our example, it told us that the centroid is where the medians meet. So I have a median here. And let me highlight that for you. This is a median. This is also a median. I don't have a median for the third side, which is fine. I just need to identify where those two cross. Those two cross at point Z. So Z is going to be my centroid. The orthocenter is where my altitudes meet. So I have an altitude here because of my right angle. This is not an altitude, this will be a median, so I'm not going to highlight that part. My other altitude is this line segment here, and I have another altitude here. So they all meet at point P. So point P is going to be my orthocenter. Point Z for my picture here was my centroid. So also in section 4 we talked about how to find the length of the centroid. Remember, whenever we see the centroid and we're finding length, we're thinking my theorem for medians, which I like to call the 2/3 theorem. So let's talk about what that means. So for problem number 7 through 12, I'm using my triangle that I have over here. And it says that x to r is 24. So x to r. So that tells me the whole length of this segment is 24. So what I like to do, just for visual, to help me out, I'm going to redraw my line. Here's r, and here's x. So the whole distance of this is 24. So then I have a point here. That's point Z. So I'm just pulling this information off of my line segment there. Then the problem says to find x to Z and find Z to R. So I need to find from here and from here. So if I know the whole piece is 24, what I'm going to do is I'm going to take 24 and divide it by 3 because I'm using the 2/3 theorem. So the longest piece of my section, that's going to make up 2/3 of my line. This last piece is going to make up 1/3. So for problem number 7, I'm going to take 24, divide it by 3. That gives me a value of 8. So I'm going to take 2 of my 8s for my 2/3 section. So that's going to give me 8 plus 8. And my 1/3 section is just going to have a value of 8. So for x to Z, that's going to have a value of 16. Z to R has a value of 8. So I'm using that same concept for all types of problems based on centroids. So, number 7 says if x to z, so I'm going to draw me a new picture. So I have x here, z is here, and I know r is on the end. So now it's telling me that x to z is 44. Now I need to find the whole line segment, and I need to find this part here. So, in order to do that, what I'm going to do is I'm going to take half of 44 to find this piece. So half of 44 is 22. So this last piece has a value of 22. And then to find the whole line segment, I'm adding the two together. So 44 and 22 is going to give me a value of 66. So now for problem 9, I'm finding V to Z. So V to Z is a new line segment, which is fine. I like to redraw it just so I don't have all this, everything over here in this picture. I just want to see what I need. And then Z is here. So all I did was I took my line segment and I redrew it over to the side. So it told me V to Z is 14. So this value here. I need to find the whole line segment and I need to find this part here. So this one is very similar to number 8. V to P I'm going to find, and I'm going to find Z to P. So 14 divided by 2 gives me 7. So I know this piece here is 7. So 14 plus 7 is going to give me the measure of the whole line, which is going to give me 21. So make sure you look back over your definitions for medians and altitudes and your definition for centroid and orthocenter for section 4.